Hey, obviously I'm not there again today. Sorry about that. My knee's just not getting better, so I need to go to the orthopedic surgeon today and have him take a look and make sure um, everything's okay. So I wasn't planning on missing, but I think you guys will be okay. So I'm going to walk you through what we're going to do today. Um, Remember, we've looked at ionic bonding, and there's three different ionic compounds. There's the easy ones. That's when you can take your periodic table and figure out what's the charge on the metals, right? Group 1 is +1. Group 2 is +2. Skip all those transition metals. Group 3 is +3. And then all you have to do is make sure the charges match up, and if they don't, you can drop and switch. We've done that. If you remember in your homework, that was page 7. We called the easy transitions. And you had to go from the name to the formula and then back from the formula to the name. So page 7 should be done at this point. If it's not, we got to figure out a way to make sure that gets taken care of. On Friday, we went on and did our transition metals. Remember, those are the metals down in the valley, and those are the ones you can't tell the charge looking at the periodic table. So we talked about to find those, you had to look at the non-metal charge, and then the non-metal charge has to balance out the transition metal charge, and that's how you could figure that out. And remember, we talked about Roman numerals. Roman numerals indicate the charge of the transition metal, and that was page 8. Remember, we identified just 9 of those. 9. 9 of those to do on page 8, and we said we're going to skip a few of those. The reason why we skipped a few is because some of them, over half of them, had what's called polyatomic ions, and so I want to quickly go over that. So if you go to the back of your periodic table, it actually looks something like this. The front side has your table of elements, but the back side has a bunch of things. So push the pause button, take out your periodic table, and then when you're ready, push play again. All right, so on the back of the periodic table, there's a number of different things. One of the things listed here is this what's called polyatomic list. Polyatomic ions are a group, poly means many, it's a group of atoms that tend to stick together and form ions. Now, my honors chemistry class, they have to learn and memorize this list. So you don't. Be very glad that you are not in honors chemistry. But you are going to have to be able to find them, identify them, and use them. And so we put them on the back of your periodic table. Remember, you can use that for every test, every quiz. This list is on here. Now, we will not use any ones that aren't on the list. But I want you to notice that a couple things on the left-hand side, we list the name of the polyatomic ion. And then on the right-hand side, we list what actual atoms are involved in there. So notice there's groups of atoms, and these guys tend to stay together. They don't break up. They stay together. Even when a molecule or a compound breaks up, these ions stay together. So, for example, the first one, ammonium, it's NH4. That's what atoms are. I got 1 atom of nitrogen and 4 atoms of hydrogen. Now, the other thing is to the right of that is their charge. Notice they're all charged. All of your polyatomic ions are negatively charged except for this first ammonium. Okay? And then we have nitrite and nitrate and cyanide and permanganate and hydroxide. The ones from nitrate down to chlorate, notice they're all with a -1 charge. Sulfite, sulfate, chromate, dichromate, carbonate, the next group here, all have a -2 charge. And at the very bottom, there's phosphate, and that is a -3 charge. Okay? So these guys are involved in ionic compounds. Remember, an ion is a charged particle. Ionic compounds are a positive charge and a negative charge that come together. Okay? So what are we doing with that? So if you would go to the homework, do me a favor and go to page 6 on your homework packet. So again, push the pause button in order to find it, and then let's go. So here's page 6 in your polyatomic ion formula writing worksheet. Okay, at the top it says give the missing names, ions, and formula. So on the left-hand side, I have the name. In the middle, here's your different ions. And then on the right, what's the formula? So the first one says sodium sulfate. The ions are Na plus 1 and SO4 minus 2. What's the formula? So remember, when we go from a name to a formula, all we do is we take the metal symbol and write that down first. For my first one, I'd write Na because that is the formula for, that's the symbol for sodium. And then I would just write the symbol for phosphate, sulfate, Well, how do I know what sulfate is? A lot of you guys are going to look for sulfur. Remember, that's sulfide. It doesn't end in "ide." If it ends in "ide," usually it's probably just a periodic table simple name. But if it ends in "ate" or "ite" or something else, then you know, hey, this might be a polyatomic. So I got to find it on my list. So I go to the polyatomic ion list. Here they are, right? So if I'm looking at sulfate, there's my sulfate, right? And my symbol for that is SO4 minus 2. All right, so then I go back to my worksheet and I go, all right, I have NaSO4 with a minus 2. Okay, well now I have to make sure the charges cancel off. So right here tells me my ions. I have Na plus 1, SO4 minus 2. Those aren't going to balance. I'm going to have to drop and switch. So the 1 is going to drop and switch over here. The negative 2 is going to drop and it's going to switch over here. All right, so when I write that formula, I can rewrite that and it'll be Na2, that dropped from here, SO4, and that 1 will drop here, but remember, we don't need a 1. That's redundant, so we can make that disappear, and that's my formula. Okay, let's try another one. Next one is lithium phosphate. So I look at my look at my periodic table, I find lithium. Lithium is Li. It's also in the first group. So if I go and look, let's find lithium together. Here's lithium, right? It's in group number 1, so it's going to have a charge of plus 1. All right, so I know it's going to be lithium plus 1. Phosphate is one of my polyatomic ions. Here's phosphate. It's a polyatomic. It's PO4 minus 3. So that's my ion, PO4 minus 3. And then I got to come up with the formula name. Clearly, these are not going to balance, right? Plus 1 and minus 3 can't balance. So I got to drop and switch. So I'm going, all right, Li3, that drops from here, PO4, and the 1 would drop over here, but I don't have to write down 1s and drop and switches. And I'm done. Okay, let's do a transition metal. Let's skip aluminum acetate and go to tin nitrate. So tin, if I go back, tin is one of these purple ones on my periodic table. Okay, it's one of those transition metals. We can't tell the charge by looking at the table. But when I write here tin 2 nitrate, that, remember, that Roman numeral tells me the charge. So I know what the ion is. Now tin, the symbol for tin, it's a weird one. I don't know why, but tin is SN. Okay? So the charge on that, what is that? I can't find it on the periodic table, but I can see it right here. So tin is going to be plus 2. And then nitrate. Don't go over here, pull out your periodic table and say, ooh, nitrate, it's nitrogen. No, it's not. If it was nitrogen, it would end in "ide." right? It'd be nitride, but it's not. It's nitrate. That's one of my polyatomic ions. So I got to find the back of the periodic table. Nitrate, where is it? Here it is. There's my nitrate, NO3 minus 1. So that's my ion. All right, so I would write NO3 minus 1. Now looking at those, I know that those are not going to balance. I have to drop and switch. So bring it over here. I'm going to go SN. This 1 is going to drop and switch to 10, to the SN. I don't ever need to write in 1s. And then I have NO3, and this 2 is going to drop and switch. Now if I put the 2 down here, doesn't that give me NO32? That would tell me I have 1 nitrogen and 32 oxygen. That's not what I want. I want 2 NO3s. Well, if I have a polyatomic ion like nitrate, and I want to say I have 2 of them, in order to show that, I have to put those in parentheses. And then I can put that subscript down there. That tells me I have 2 NO3s. So the formula is SN NO3 2. All right. So I want you to do your best here today. Work through, try and see if you can get all of page 6 done. Okay. If you can get page 6 done, that's fantastic. Now, 7, remember we did. 8, remember we did 9 of them. Now you should be able to finish the rest of page 8 because you have things like nitride, polyatomic, hydroxide, polyatomic, acetate, polyatomic, nitrate, carbonate. Those are all polyatomic ions. Up till now, maybe those didn't make sense to you, but now you can go through and figure those out. Okay? So again, homework today while I'm gone. You should be working on page 6. Get that whole thing done. And again, I'd love it if you worked with a partner or a group. That'd be fantastic. 7 should already be done. And then page 8. So when I come back tomorrow, when I see you tomorrow, you should have 1 through 8 done, ready to go. Hope that made sense. We'll see you tomorrow.